Okay, homework for 3.3b, solving exponential equations. Okay, so this is like the changing base portion of it. So for 1a, we have 2 to the x equals 16. We know that we want the same base here. So how can we get 16 as a base of 2? Well, 2, 4, 8, 16, it's 2 to the 4. Now that we have the same bases, you cancel out, x equals 4. Okay, b, we have the same number. We're still working with a 2. So we have 2 to the x equals, and 2 to what exponent equals 128? I get 7. So 2 to the exponent 7 equals 128. So we can substitute 2 to the 7 in directly. We cancel out the bases since they're the same, and we get x equals 7. Okay, so we get negative 3 to the exponent x equals negative 27. Okay, so we're going to change the negative 27 to a base of negative 3. Okay, so negative 3 to what exponent equals negative 27? It's 3. Cancel out the bases, x equals 3. Okay, I'm going to take 2a up here. We get 7w minus 2 equals 49. Okay, so how can we rewrite 49 as a base of 7? Well, it's 7 squared. We can now cancel out the bases, and we have w minus 2 equals 2. Bring over the negative 2, we get w equals 4. Okay, b, we have 5 to the 3x minus 1 equals 25. So this 25, how can we rewrite it as a base of 5? Well, 25 is just 5 squared. We have the same base. Cancel out the bases. We get 3x minus 1 equals 2. Bring this over. 3x equals 3. And then we can divide out the 3's. X equals 1. Okay, we'll bring c down here. So I get, for c, 3 to the 2 minus 2y equals 1. Okay, this is a tricky one because when we see 1, we're like, okay, well, we can't change the exponent 1, or sorry, 1 as the base, because 1 times 1 is always going to equal 1, no matter how many times you put it beside each other. So we actually have to go with the bigger base, which is 3. Okay, so think of it like this. 3 to the 2 minus 2y equals 3 to the what exponent? Well, the base to any base to what exponent equals 1? 0. Okay, so we can cancel those out. We get 2 minus 2y equals 0. And then we can bring this over. We get 2 equals 2y, and then divide out. We get y equals 1. So anytime you see a 1, we know that it's that number raised to the exponent 0. Okay, on to 3a. We have 6 to the x plus 3 equals 6 to the 2x. These are already the same base, so let's just go ahead and cancel them out. We get x plus 3 equals 2x. Bring that x over. 3 equals x. Okay, for 3b, what we have to do is we have to find a base that 16 can be rewritten as, and 8. So that base is 2. So I think this is 2, 4, 8, 16. This is 2 to the 4, right? And I bracket this because this 16, like it's bracketed, we do a straight substitution. These two are equivalent. And then to the 2x, then 2, 4, 8. So this is 2 to the 3 to the 3x. Okay, we can drop the 2's. We have 4, 2x, and then 3, 3x. So I get 8x equals 9x. Okay, we take this and we bring it over. 0 equals 9. It'd be like 9x minus 8x. So 0 equals x. Okay, and then the last one. We have 9 to the 2q minus 6, and then 3 to the q plus 1. Okay, so I'm going to change this 9 to a base of 3. So we'll get 3 squared, and then bracketed. So 3 squared we can bracket, and just remember to keep the 2q minus 6 together as the exponent. Okay, and then 3q plus 1. Because when we drop these 3's, what happens is we have 2 and then 2q minus 6. Okay, this 2 has to be distributed into that bracket. So we actually have 4q minus 12 equals q plus 1. Okay, a lot of individuals will only multiply the 2 by that first term, but we have to distribute it. Okay, bring that q over, bring that negative 12 over. I get 3q equals 13, so I get 13 over 3. Okay, so number 4 gets a little bit more complex. So now we're dealing with exponent laws, with more exponent laws with changing base. So when I take a look at this equation, I notice our bases are 8, 4, and 2. I'm going to change every single one of these to a base of 2. Okay, so this is 2 cubed to the 2x over, so we have 4, which is 2 squared to the x minus 1 equals 2 to the x plus 1. Okay. I'm actually going to do this one a little bit differently. I'm going to do power to a power. So I'm going to express this as 2 to the 6x. And then I'm going to actually distribute this 2 here. So this is going to be 2 to the 2x minus 2. And then we have 2 to the x plus 1. So this is the reason I did that. When we have the same base, we can subtract the exponents. That's like an exponent law. So what I'm going to do is I'm going to rewrite this fraction as 2 to the 6x minus, and you have to bracket it because we have to subtract this entire thing, 2x minus 2. Okay, and then just write the right-hand side as it is. So I get 2 to the 6x minus 2x plus 2. And that was just me distributing that negative sign in. Okay, so what I'm left with is 2 to the 4x plus 2 equals 2 to the x plus 1. Okay, at this point, I can drop the bases because we only have the 2 bases. Okay, so go ahead and drop the bases. I get 4x plus 2 equals x plus 1. Okay, bring this x over, bring that 2 over. I'll get 3x equals negative 1. So I get x equals negative 1 over 3. Okay, I'm going to do the same thing for this equation. I'm going to change the 8, the 4, and the 2 to all the same bases. So I'm going to use, again, a base of 2. So 2 to the 3 to the 2x. 4 is 2 squared to the 2x. And then 2 to the x plus 1. Okay, I'm going to simplify this. So we have 2 to the 6x times 2 to the 4x equals 2 to the x plus 1. So when we have, in exponent laws, when we have two terms multiplied by one another, and we have the same base, what we do is we add the exponents. Okay, so add those. So I get 2 to the 10x equals 2 to the x plus 1. Now I can drop the bases, and I have 10x equals x plus 1. And I have 9x equals 1. Divide out. I get x equals 1 over 9. Okay, so for C, I have the bases of 9, 3, 27, and 81. So I'm going to change all of these to a base of 3. So 9 is 3 squared, and I get 2x minus 1. And then 3 is just normal. So you know what? I'm just going to simplify this a little bit. I'm going to collect these exponents. So I'm going to write it as 3 to the 6x. Okay, and that's over 27. So 3 cubed to the x plus 2 to the cubed. That I can see getting a little bit confusing. And then 3 to the exponent 4 to the exponent 3. Okay, so let's just simplify a little bit. So this 2 and then 2x minus 1, I'm actually going to expand this. Okay, so I'm not going to write that step, but I'm going to expand it here. So I get 4x minus 2. Okay, I'll write 3 to the 6x as it is. Now this, 3 times 3 is 9, so I'm going to multiply these two to a 9 and then distribute. So I get 9x plus 18. And then here I get 3 to the 12. Okay, so in the numerator here, I'm going to collect these because they're multiplied by one another, so I'm going to add them. Okay, so again, I'm not going to write it out this time. 6x plus 4x is 10x, and then minus 2. And everything else, I'm going to just rewrite. Okay, so what I'm doing here is we're dividing two numbers, so we're going to subtract the exponents. So I have 3 to the 10x minus 2 minus 9x plus 18. And remember to put that in brackets because we're distributing that negative sign in there. So in other words, 10x minus 2 minus 9x minus 18 is the exponent. Okay, so 10x minus 9x is just x. Negative 2 minus 18 is negative 20. And then that equals still 3 to the 12. I finally have two bases that are the same, and there's just one term on each side. So I'm going to drop the bases and solve. Okay, so I get x equals 32. Okay, likewise for D, I'm going to rewrite the 8, the 4, and the 16 all as bases of 2. So I get 2 to the 3 to the 1/4 times, this would be 2 to the negative 2. So usually 4 is 2 squared, but because it's 1/4, we have to change that negative sign, or that exponent, to a negative. X over 2 equals 2, 4, 8, 16, 2 to the 4 to the 3/4. Okay, so I get 2 to the 3/4 times 2 to the, these 2's cancel out, negative x, equals, these 4's cancel out, I get 2 to the 3. Okay, I'm going to add these two exponents to negative x plus 3/4, and now I'm going to drop the bases. So I get negative x plus 3/4 equals 3. Let's bring this x over so it turns to positive x, and I'll bring this 3 over so it's negative 3. So 3/4 minus 3. Okay, so I get x equals negative 2.25. Okay, number 5a, 10 times for 3 to the x equals 270. Okay, so for me, I would divide both sides by 10, and I get 3 to the x equals 27. And then 3 to the x equals 3 to the exponent 3. And we're back with x equals 3. Okay, we can't have this this constant, like multiplied by 10 in front of 3 to the x. We just have to have like some term with like a base to some exponent equals, and a base to like some exponent. Okay, that's the format that we have to have this in. For this one, what I'm actually going to do, this is you're going to see this in advanced functions, not so much, not too much in this course, but what I'm going to do is I'm going to factor out a 4 to the x. Okay, so we have 4 to the x, and then bracket, that's going to equal 1. And then if you think about exponent laws, like 4 to the x plus 1 divided by 4 to the x, what we're doing is we're subtracting. So the x's cancel. So I get x plus 4 to the 1. Right? Because another way of saying 4 to the x plus 1 is by saying 4 to the x times 4 to the 1. Okay? Because remember, when we have the same base, you add the exponents. And that equals 40. So I'm going to just simplify this a little bit. This is going to equal 5. So I'm going to divide both sides by 5. I get 4 to the x equals 8. We're going to go 2 squared to the x equals 2 cubed. So I get 2x equals 3. Divide both sides by 2. X equals 3 over 2. Okay, we're on to C. So we have a base of 16 and a base of 2. So I'm going to change both of these to a base of 2. So 16 is 2 to the exponent, 2, 4, 8, 16, 4. And then I'm going to bracket that, and then we have x squared plus 3x. Okay, and I'm going to write the right-hand side just as it is. Okay, so we can go ahead and draw the base. So we have 4, and then we have x squared plus 3x equals x squared plus x plus 4. Let's distribute that 4 into the bracket. 4x squared plus 12x equals x squared plus x plus 4. So what I'm going to do is I'm going to bring everything to the left-hand side. Okay, we would have 4x squared minus x squared plus 12x minus x minus 4. Okay, so let's collect these. 3x squared plus 11x minus 4. Okay, so all we've done is got this down. We changed so that we had the same base. We canceled the bases. We expanded and simplified. Now we actually have to solve for x. So what two numbers multiply to negative 12 and add to 11? Remember, this term, or this is a trinomial with an x squared and an x, so we can't just directly solve. We have to factor. So I have 1 and 12, and I would put the negative on the 1. So these two multiply to negative 12, add to 11. So let's break down that middle term. 3x squared minus x plus 12x minus 4 equals 0. And we're going to factor by grouping. So out of the first two terms, we're going to factor out an x. Out of the second two terms, we're going to factor out a 4. So I get 3x minus 1 plus 4, 3x minus 1. Okay, so we have x plus 4, 3x minus 1 equals 0. So our two x values, so this occurs when x equals negative 4 or when x equals 1 over 3. Okay.